Welcome you all to the fluid power system. This is module 2, lecture series 5. Okay. Actuators. See, in the fluid power system, actuators are the power utilizing elements. See, when the power or energy is output from the pump, it is goes to hydraulic actuators. So these actuators consuming that power to complete the assigned work. Okay. These actuators are used to convert energy of the fluid into mechanical force or mechanical torque to do useful or assigned work. See, as I told, the pump output directly goes to actuators. So for actuators assigned some work to complete it using that energy. So actuator consumes that energy to complete useful work or assigned work. The pressurized fluid is supplied to the actuator by pump, and the actuator converts the energy of the fluid into mechanical energy. This mechanical energy is used to get the work done. Classification of actuators. See, the hydraulic actuator can produce linear, rotary and oscillatory motions. Hydraulic actuators can produce linear motions like left to right, front to back and up and down movements. So such kind of movements or motions are called linear motions. Rotary motions, circular motion, either it is clockwise or anti-clockwise, such motions are called rotary motions. And third is oscillatory motions. For some certain angle it travels, not complete rotation. For example, see, in the wall clock there is a one pendulum. In olden days or what we call a few years back, there is a one wall clock. In wall clock there is a one pendulum. Pendulum will oscillate for certain angle. Such type of movement is called oscillatory motion. So the classification of actuator mainly based on linear motions, rotary motions and oscillatory motions. They can be used for lifting, tilting, clamping, bending, push, pull and many other similar applications. Okay. Actuators are used for lifting some load, lifting load, tilting, clamping, bending, push, pull. So similar kind of applications can be done. Depending on the type of actuation, hydraulic actuators are classified as: first one are linear actuators or cylinders. These actuators will provide linear movements. So in such cases, linear actuators or cylinders are utilized. Second one is rotary actuators or motors. These motors will provide rotary motions, circular motions. In such cases, rotary actuators or motors are utilized. And third one is semi-rotary actuators or oscillatory actuators. Okay. Semi-rotary means it is not a complete rotation. it will produce or provide some certain angle rotation. So in such cases semi-rotary actuators are utilized. First one, we will linear actuators or cylinders. Linear actuators are used to convert hydraulic power into linear mechanical force or linear mechanical motion. Okay, linear actuators are consume hydraulic power and converts it into a linear mechanical force or linear mechanical motion. Hydraulic cylinders extend and retract a piston rod to provide a push or pull force to drive the external load along a straight line path. Okay, linear actuators means a straight line path, whether it is a horizontal line or vertical line or any inclined lines. Okay, so hydraulic actuators, there is a two new terms or new two words, extend and retract of the piston. You will come to know later. Classification of linear actuators. Okay, see, the linear actuators types are single acting actuators, double acting actuators, telescopic actuators are cylinders, tandem actuators are tandem cylinders. Okay, we will move on to first one, single acting cylinders. See, single acting cylinder, as the name implies, the cylinder consists of only one port or only one flow path. See, look at here, this one, it has only one path through which the fluid will in and out through same port. So single acting actuator. And extension and retraction. See, look at here, in the construction, this one is the outer body, and inside there is a piston, and piston is connected to piston rod. Okay, see, when the fluid comes through this port and acts towards piston surface, so the piston travels outward. The piston travel outward. This stroke is called extension stroke. Extension stroke. And after completion of the work, the piston travels to its original position by its gravity weight or by its spring force or any mechanical means. So to return its original position, the piston travels towards inside. That stroke is called retraction stroke. Okay, this one is a symbolic representation of single acting cylinder. See, here only one port is provided through which the fluid is inlet and outlet happen. And look at here, some valve connection. See, from the pump, here this one is the pump. From this the pump output connects to valve, and the valve, through this the liquid connects to actuator, and the fluid acts like this. The piston travels outward when this valve position connects like this. Okay, for a retraction, like this. See, whatever the liquid accumulated or filled in the space of cylinder, it travels towards outside, so it connects the valve like this. from this it towards R means reservoir. Okay, by this way the single acting actuator will work. In single acting actuator, again two sub classifications: gravity or self return cylinder, and second type is spring return cylinder. First one, a gravity or self return cylinder. See, look at the diagram. Here is the construction. Here is the port for fluid in and fluid out. And in this construction, see, first type there is a push type, and second B diagram indicates pull type. See what it means. Here the fluid acts on the piston travels upward, so it lifts the weight or push the weight. So here the piston travels against the weight, so it pushes the weight or lift the weight, hence the name push type cylinder arrangement. And once the operation is completed, assigned work is completed, see, because of self weight of the piston or gravity force, the piston will come back to its original position. And here the port is provided at the piston end. See, this is the piston surface. The piston end, the port is provided. So, and when we go for a second type, pull type, in pull type, see, the port is provided at rod end. So here, because of this action, means the force of a liquid acts in this direction, the piston travels upward like this. It drag the load or lift the load. Okay, so this is the application of pull type or drag type. Okay, and this is the symbolic representation of gravity or self return cylinder. See, extension happens due to force of liquid, and retraction happens with the help of self weight of the piston or gravity force of the piston. And the here one limitation is there. In such cases, the cylinders are placed in only vertical positions. Suppose if you keep it in a horizontal position, there is a problem in retraction of the piston. So to retract of the piston, some additional arrangements should be made. Second case, spring return cylinder. Look at this. Compared to previous case, here at rod end spring is attached. Okay, here is the port for both inlet and outlet, and once the extension happens, extension means the piston travels outward, complete the work like push the load or what we call pull the load, whatever. Okay, it completes its work, then it will retract to its original position. It happens with the help of this spring. See, during extension, the piston travels against the spring force. The spring gets compressed. So, extension stroke happens. And for retraction, see, the spring will expand. Because of that spring, the piston travels to its original position. Hence, it is called spring return cylinder. Okay, and this is symbolic representation of the cylinder, spring return cylinder. And the advantage of this spring return cylinder is we can keep it in any positions like horizontal position, vertical position, inverted positions, or inclined positions. Any what we call in any angles we can keep it. This spring ridden cylinder. Look at the animation. Next, second classification, double acting cylinders. As the name implies, the cylinder has two ports. During extension, one port acts as inlet, another port acts as outlet, and retraction, again some ports means will come to know by diagram. See, during extension force, this one act as inlet and this port act as outlet. When retraction, this one act as inlet and this one act as outlet. See, during extension, this port is connected to pump. The force of the liquid acts like this. The extension of the piston happens. Here the liquid accumulated in the piston rod end, it will travel towards the reservoir. Okay, this is extension stroke. And during retraction stroke, the pump is connected to this port and the force of liquid acts on piston rod end and it pushes the piston to its original position, and whatever the liquid accumulated here, it will travels to this port and this port connected to the reservoir. By this way, double acting cylinder works. Look at here, during extension stroke means outward stroke, this one is act as inlet and this one act as outlet. This one is inlet, this one is outlet during extension, and during retraction this port acts inlet and this port act as outlet. Look at this. Extension, retraction. During extension, suppose if you consider this one as port number 1 and this one is port number 2. During extension of the stroke, port number 1 acts as inlet, port number 2 acts as outlet, and during retraction, port number 2 acts as inlet and port number 1 acts as outlet. This is the symbolic representation of double acting cylinder. Look at here in this diagram, we can understand extension and retraction by using some valve attachments. See here, there is one blue colored line. This blue colored line indicates there is a pump line. See, this one is connected to pump. The pump connected to this flow path. From the pump, the fluid moves like this and connects the pipeline towards actuator, and here the piston, the liquid force acts on this piston like this. The piston travels outward, and whatever the liquid accumulated over here, it travels like this, connects like this, and here this is for reservoir. This is for reservoir, and it happens during extension stroke. Extension stroke here, plus indicates extension stroke. And for retraction, see the what we call this valve connects like this. This is the pump, and from the pump it connects to the port like this, act on the piston like this. So the piston travels to its original position, and whatever the liquid accumulated over, it connects like this, it moves like this and connects like this. See, this one is connected to reservoir. By this way, what we call extension stroke and retraction strokes happens during double acting cylinder working. Next is classification of double acting cylinder. Here first type, differential cylinder. Look at this. See, why it is called as differential cylinder means, see, it has there is a piston. The piston has only one rod at one side, another side is free end. And see, during extension stroke, what will happen? During extension stroke, this one act as inlet and this one act as outlet. So the force acts like this. The force acts like this. Okay, extension happens. Okay. And during retraction, what will happen? This one acts inlet, this one acts outlet. So see, the force acts only this small annulus area. So there is a difference. There is a difference in action of the force through liquid. So here there is a difference in the force. Hence the name differential cylinder. Okay. During extension stroke, the liquid force acts on the entire piston surface, but during retraction stroke, the liquid acts on the only a small annulus area. Annulus area means piston area minus a rod area, whatever that remaining area, that is called annulus area. So there is some difference in the forces. Hence this construction is called differential cylinder. See, look at here, you come to know. During extension, the force acts on entire surface of the piston. During retraction, only this much. This is annulus area. Okay. And second one, a non-differential cylinder. See, as the name tells, there is no any difference in the action of a liquid force towards the piston. So here in this arrangement, the rod is attached either ends of the piston. So there is no difference in the action of force. See, look at here. The force acts an annulus area in either ends of the piston. So it is non-differential cylinder. This one is symbolic representation of the non-differential cylinder. This one is symbolic representation. Okay. And third main classification, telescopic cylinders. It is used when long stroke length required or short retracted length required. In such cases, telescopic cylinders are utilized. And also it is used where there is a space constraint. Where there is a space constraint, in such cases telescopic cylinders are utilized. Look at the construction of telescopic cylinders. See, this one is a retracted position and this one is extended position. See here, this telescopic cylinder has a number of sleeves. So in retracted position, by its gravity force or some any mechanical means, the sleeves are compressed or retracted. When the liquid force acts on this pressure port, this port, so one by one the sleeves are extended. First, see stage 1, sleeve 1 extended, next sleeve 2 or stage 2 extended, next sleeve 3 or stage 3 extended. So in this structure it has three sleeves or three stages till there it extends. Okay, and similarly as the liquid comes out of the cylinder, the all extended sleeves will come to the its original position like retracted. So stage 3 will come retracted, then stage 2 retracted, then stage 1 retracted, and comes to its position like this. Okay, and it is used to where long stroke length required or short retracted length required, or where there is a space constraint. In such cases telescopic cylinders are utilized, and this is symbolic representation of telescopic cylinder. This one here single acting telescopic cylinder, and this one double acting telescopic cylinder. And the last type, tandem cylinders. In tandem cylinders, see more than one piston is connected, means two cylinders are placed in series and more than one piston is attached to the common piston rod. Look at this. You can mention here cylinder number 1, cylinder number 2, piston number 1, piston number 2. Here two pistons are connected to only one piston rod, common rod. Okay. Here see port, this is for inlet and this is for outlet for cylinder 1, and this is for inlet, this is for outlet for cylinder 2. So at a time inlet happens during extension stroke. See, the inlet happens like this. So more force is required for extension. So here higher amount of force is utilized. So what it indicates means wherever more force required, higher force required, in such cases tandem cylinders are utilized. And for retraction also, see the force acts like this. For retraction like this. For extension the forces acts like this. Okay. Tandem cylinders are also called as combination of cylinders. Here more than one cylinders are attached in series. Two separate pistons are mounted for same connecting rod, means piston rod. Two double acting cylinders are connected in series, and it is suitable for higher force applications. Okay, with small cylinders you can produce higher force. Two cylinders, so the force gets twice. High volume of oil is required to drive the cylinder, as at a time two inlets are acting, so consumption of oil or volume of oil consumption is more to drive the cylinders, and this allows you to have a greater forces without increasing the size of the cylinder bore. Without increasing the diameter of the cylinder, we can achieve a greater forces. Tandem cylinders are used in places where there is a insufficient space to increase the size of the cylinder bore. So there is some space constraint to increase the diameter of the cylinder. In such cases tandem cylinders are utilized. So without increasing the diameter, two cylinder or more than two cylinders or more than one cylinder is attached in series. So here the force will get in a greater manner or higher manner. By this way the tandem cylinders are utilized. Okay. See, these are the concepts comes under linear actuators. In linear actuators mainly used for straight line paths. Application is straight line paths. So here classifications are linear actuators. First one is single acting, double acting, telescopic and tandem cylinders. Thank you.